All right, and we are back to it again. Today we're going to talk about dilations in the coordinate plane, which is another type of transformation. All right, so you've talked about translations. All right, you talked about reflection so far. And when you talked about those two things, all right, your scale has been preserved. So when we translate something, when we reflect something, all right, the size of our shape does not change. That's going to change today when we talk about dilations. All right. So when we talk about dilations, this is Unit 1, Lesson 6, and this is page 26 to 29 in your workbook. All right. And so if you want to do the opener, all right, you can do that. But I'm going to jump right into our vocabulary today. All right, and talk about exactly what, all right, a dilation is. And now, just by the definition, you can see that how this is going to be different, all right, than your reflections and your translations that you've already learned about. So dilation is a transformation in which a figure, all right, is enlarged, all right, or reduced, all right, with respect, all right, let's see if we can get that E and that CT there, all right, to a fixed point. Trying to make sure I could fit it all in, all right, to this little box there. All right, a transformation in which a figure is enlarged or reduced with respect to a fixed point. So you can see right now we're already going to change the scale, right, the size, all right, of the dilation. All right, the shape will stay the same. So a triangle will still be the triangle, right? It'll still look similar, all right, but it's going to get bigger or smaller, all right? All right, so for example, if we think about having, all right, a triangle like this, right? Okay, so if we're going to dilate it, we might enlarge it, and then it might look something like this. All right, so it's going to have the same shape, right, but it's going to become bigger or smaller. All right, now when we talk about this fixed point, we talk about that as the center of dilation. So that's where we are enlarging it or reducing it to in regards to, right? So this is the fixed point, all right, in a dilation. Now, for everything that we do, all right, in this particular lesson, in this particular unit, our center of dilation is always going to be the origin. So we're going to do everything in relation to the origin, all right? The math gets a little bit more complex when, all right, we do it around a different point, all right, other than the origin. So we're going to focus on our center of dilation will always be the origin, all right? So when we think about our coordinate grid, right, the origin right there, and you can kind of see that's what I did with my picture up there. All right, so now, when we do this, when we talk about enlarging or reducing, we get into changing the scale, and that gives us something called a scale factor. And the scale factor is the ratio, all right, of the lengths of the corresponding sides, all right, of the image, all right, and the pre-image, all right, of a dilation. All right. Okay, so there you go. So the image and the pre-image. All right. And so you can see pre-image is before, right? So pre means before, so that's before we perform the dilation, and the image is the result after. All right. And then once again, we're going to use those primes, all right? Okay. All right, to denote, all right, what happened after the dilation. So if I have, all right, let's just say I have A, B, C here, correct? And let's say we have an equilateral triangle, and all the sides are 1, right? Then I would perform my dilation, and it can make that triangle bigger, and this would be A prime, B prime, and C prime. And now maybe they all have, all right, side lengths of 3. So my scale factor, depending on which way we go, there's actually 2 ways you could look at it. All right. So if we go from the image to the pre-image, that would be 3 to 1. All right. So my scale factor is 3. So it's 3 times as big as it was before. All right. So once again, if I'm moving too fast, you need more time to write or copy things down, pause the video, take your time with that, all right? So now moving down to some of the notes here. All right, so once again, just kind of re-emphasizing the vocabulary from above. A dilation is a transformation in which the figure is, right, enlarged or reduced with respect to a fixed point. All right, and you can kind of see here, right, there's that fixed point, right? So there's our original quadrilateral, and then you can see that it was enlarged from that. All right, so to dilate, or to find out how much a figure was dilated by, we need to know, all right, the scale factor. All right. And then we need to know, okay, what we're dilating from, all right, and we said that that would be our center of dilation, right? And like I said earlier, for everything that we do, all right, our center of dilation is going to be the origin, or 0, 0. All right, so let's get into a little bit of some examples here. So if you want to go ahead and flip the page, and let's look at page, all right, 27 here. All right, and so just a couple things to think about. So when we say the scale factor is greater than 1, all right, what do you think is going to happen to our figure? All right, hopefully you said or you thought that, all right, it's going to get bigger or it's going to enlarge, right? So if our scale factor is greater than 1, all right, our figure is going to get bigger. All right. What happens when the scale factor is less than 1? Well, you're right. Okay, when the scale factor is less than 1, all right, it's going to get smaller, right? So that's the reduction, that's the enlargement, right? And that should make sense. So if I want something to be twice as big or 3 times as big, right? Okay, we need a scale factor greater than 1. All right, if I want something half the size, right? Okay, I want that scale factor to be less than 1. All right, so notice, well, what if the scale factor is equal to 1? All right, so then we maintain our size. All right, and that's what happens, all right, when you do a reflection, all right, and you do translation, right? That scale factor stays at 1, right? All right, so it preserves that distance, okay? And so we have 2 terms here. We have similarity and we have congruency. So similar means they have the same shape but different sizes, and that's what happens with a dilation. When we talk about congruent figures, they have the same size and same shape, which is an isometry, which is what you get from reflecting and translations. All right, so let's take a look at a couple examples here. Let's look at 4 and 5 here, and let's look at what we want to do here. All right, I may have to zoom out a little bit here to get both the picture and the table in here. All right, so it says use the use the origin as the center of dilation and dilate the figure by a scale factor of 2. So here's all we have to do, all right, is look at our points, all right, and if we look at our points here, if I just kind of go from M here, all right, that is -2, and then A, all right, is 3, 2, and then L, all right, is 3, -2, all right, and then S, all right, is, what is S? Is that, we're on the axis there, so that's -4, 0. All right, or no, is that below the axis? Oh, that is -4, 1, sorry. All right, -1, so it's hard to see with our lines here. All right. Now, all we have to do is we have to just apply the scale factor, all right, to each point. So if we have a scale factor of 2, we want to multiply everything, all right, by 2. So what that tells me is that M prime now is going to be -4, 4. All right, so let me see if I can, so here's my origin. I'm going to put that in so I can count from that a little bit better here. So 1, 2, 3, 4, all right. -4 and then +4. 1, 2, 3, 4. So there's M prime right there. All right, so now A prime, if I multiply that, would be 6, 4. So there's 5, 6, and then 1, 2, 3, 4. So there's A prime. All right, and then for L prime, that would be 6, -4. All right, so 6, and then down 1, 2, 3, and then there's -4 right there. And then we do them one more time with S, right, to get S prime, and that's going to be -8, -2. All right, so when I go here, so there's -5, 6, 7, 8, and then -2, there's S prime. And then if I draw that in, all right, once again, a little hard to see here, but you can see we have the same shape. Okay, it's the same shape, all right, but now it's just a bigger shape, and that's what dilation does. All right, let's go through and do number 5 together, and then we'll be finished for today, all right, with this video. So now we're going to dilate, all right, but now we're going to have a scale factor of 1/2. So once again, if I just look at my 3 points here, if I do x, y, and z, so x is -8, -6, all right, y is -4, 2, and then z is 4, 2. Now, once again, our scale factor is 1/2. So I'm just going to multiply everything by 1/2. And that's going to make our coordinate smaller. So now x prime, if I multiply this by 1/2, all right, is going to be -4, -3. So -4, 1, 2, 3, 4, 1, 2, and so there's x prime right there. Y prime now, if I multiply that by 1/2, would be -2, 1. So there's -2, 1 right there. So there's y prime. And then z prime, if I multiply that by half, would be 2, 1. So 1, 2, and 1 right there. And you can see that once again, if I draw that in, all right, we get, all right, the same shape, just a different size. And now you can see that because that scale factor is less than 1, we have now reduced, all right, the size of our shape. All right, and so that is how you perform a dilation. All right, so just take your scale factor and apply it to each individual point of your shape. All right, and you should be successful. So now when you look at the work left for you, you have 6, 7, 8, and then you have problem 9 here on page 29. And then we will see you next time.